So inverse functions. What are inverse functions? Well, inverse functions, if functions are inverses of each other, if the x's and y's are switched or flopped, flip-flopped. Okay? So if I have two functions and the x's and y's are in flip-flopped, switch places, they're called inverses of each other. Okay, couple things. That means their domains and their ranges. Domains are the x's, ranges are the y's. Those would be swapped as well. If I were to graph both a function and its inverse, both of those graphs would be symmetric over the line y equals x. And if f and g are inverses of each other, then when I plug g into f, it should equal the same thing as g into f, the opposite, okay, if they're inverses of each other, okay? For f to have an inverse, it must be 1-to-1. So 1-to-1 means it passes the horizontal line test. So you guys know about the vertical line test, right? You guys have heard about that probably in Math 1. So the vertical line test means if I have a graph and I move my pen across the line. So let me draw a graph. Okay, so that graph right there. So that's that parabola right there. That would pass the vertical line test, right? The vertical line test means you get your pencil vertically. Shh, BC, guys, quiet. Okay, so you put your pen across and you move it from left to right. And if it doesn't hit at the same spot more than once, it passes the test, right? This guy passes the test. I'll give you something that wouldn't pass the test. Let me see. Let me draw another. Let me draw you another example. So this guy here. Let's see here. That guy would not pass the vertical line test because if I were to move my pen and move it from left to right, it would hit at top and bottom, two places at once. Means it's not a function, right? That means we use the vertical line test to see if it's a function or if it's a non-function, okay? So this guy here would be a function because it doesn't hit at more than one spot, okay? The horizontal line test is the opposite. So you turn your pen around and you move up and down instead of left and right. This guy right here would fail the horizontal line test. So that means it doesn't have, it's not what we consider 1-to-1. Okay? This guy here would not have a, it's not going to have an inverse. The inverse, it will not have an inverse. So anything x squared, anything quadratic, won't have inverses. Okay? That's what it means. That's what that means. Monotonic, always increasing or always decreasing. So functions have to be always increasing or always decreasing. Well, this guy isn't, right? This guy is decreasing here, and then it switches to increasing afterwards. That's what it's talking about. Monotonic means it's always doing one thing. Linear, right? Linear. Something linear is always increasing or always decreasing, right? That's monotonic. Okay? Those guys are the ones that will always have inverses. Okay? Those are the guys that will always have inverses. The inverse function is denoted, so we have a new notation. It's not new if you've seen it before. So it's f to the -1. Anytime you see f to the -1 of x, that means an inverse. That means it's an inverse of f. Okay? And then it undoes the work of the f. So first thing we're going to do is, if you've never done it before, we're going to find an inverse. Okay? So f of x. F of x is linear, right? It's linear. So that means it will have an inverse. So to find its inverse is not very hard. The directions are right here. You just swap x and y. Okay, so let me take out the f of x and let me put a y. Because f of x is the same thing as y. Okay. First step, switch them. So everywhere I see an X, I put a Y. Everywhere I see a Y, I put an X. That's the first step. Last step, solve for Y. Subtract 2 from both sides. Divide by 6. So we get Y equals, I'm going to break this up to 1 6x minus 2 6, which is 1/3, because they're both divided by 6, right? Both x and -2 are being divided by 6, so I just gave them each a 6, and then I reduced the fraction. So this guy here and this guy here are both inverses of each other. If I was to graph both of them, they would reflect across this line here. If I was to graph both of them, they would reflect each other across that blue line there. That's the line y equals x. So if I was to graph them both on Desmos or graphing calculator or do it by hand, if I had a dot, like for example, this guy right here, if I plug in 0, I have a dot at 2, 0, 2. Right there. For the other guy, if I plug in 0 for x, I'll have a dot at -1/3. Plug in 0 for x. Wait. Plug in 0 for x. But I did that wrong. If I plug in 0 for x, 0, 2, so it would be have a dot right here. No, that's right. I had it right before. The other one would have a dot that reflects across the blue line. That means they're inverses of each other. Okay? Okay, so let's do another one. Let's find another one. This guy here, square root. Okay? If we're finding the inverse of this guy, we say, well, first of all, y equals x minus 5 plus 3. Switch x and y. Plus 3. Solve for y. Okay, so I'm going to subtract 3 from both sides. X minus 3 equals the square root of y minus 5. Then I have to undo the square root, which means square both sides. Add 5 to both sides. Y equals x minus 3 squared plus 5. Okay. That's how you find an inverse. I'm not going to ask you today to find an inverse. What I'm going to ask you is, I'm going to give you an equation, and I'm going to say, what is the derivative of its inverse? So what I'm going to do today is I'm going to do this. I'm going to say, okay, that's f of x. What I want you to do is find its derivative, not of f, of its inverse. Okay, that's what I'm asking you to do. I'm not going to ask you to do this as a math 3 thing. You guys did this in math 3, where you guys found inverse equations. That's not what we're doing. Again, what I'm going to ask you to do is say, I want you to find the derivative of this guy's inverse. One way of doing it is by finding the inverse and then finding the derivative, right? So the derivative of this guy's inverse would just be 1/6, because the inverse is right there, right? Some equations, though, aren't that easy. Some equations are a little more complex. So we have to have a different way of doing it. And we do. If you look at the next page at the bottom, the very bottom, right here, this is going to be your lifeline for today. This guy right here. Okay, because these are the two ways we're going to find them. These are the two things we're going to use to solve these problems. Anytime it says find the derivative of an inverse function, you're going to use one of those two guys there. Okay, which one are you going to use? Well, it depends which they ask for. If they write the notation like this, we're going to use this guy. If they write the notation like this, we're going to use this guy. So it just depends on what notation they use. Those are the two guys we're going to use. Okay? These are the two guys for inverse functions, these are the two guys that we're going to use, we're going to stick with. So look at the notations in here. It's always over 1, right? Always over 1. 1, 1. F prime. We know how to find F prime. F negative 1. Inverse, right? Down here, it's even easier. It's just F prime and G. Well, G is the inverse. So they're the same thing, just one is with a G, one is just straight Fs. Okay, a tip. It may be helpful to write out tables. Write out tables to solve these guys. Trust me, this is one of the more, I don't want to say difficult, but it is one of the things that students struggle with. This is the one lesson that students struggle with the most. I struggle with this lesson sometimes. Before I teach the lesson, I have to go back and look at my notes to see, okay, I've been doing this I've been teaching this class for 5 years, and I still have to do it because it can be confusing sometimes, okay? So most lessons I don't. Most lessons I'm like, oh, what am I teaching? Oh, okay, print out the notes. I remember it. This one I have to really think about it, okay? So anytime we can make it visual, it's easier. How do you make it visual? One way to do it is by writing out tables, and I'll show you how to do that, okay? Okay, so let's look at one. Let's look at the back example. Okay. All right, find the derivative of the inverse functions. It gives you f. And then it says, I want you to find not f's derivative, I want you to find the inverse of f, and then its derivative, and then plug in 3. That's what they said. That's what this says. That's what this command says. This command says, I want you to find not f's derivative, I want you to find the inverse of f. And then I want you to find the derivative of that. And then I want you to plug in -3 and give me an answer. Okay? Well, here's the thing. Watch. Don't write this down, but I'll show you. Sometimes you'll be like, oh, okay, let's just switch x and y, right? Let's just do what we did before, right? We'll switch x and y. You don't have to write this part down because I'm going to show you. I'm going to show you what happens here. All right, so we switch x and y. Done. And then what was the next step? What did we do what did we just do before? After I switch x and y, what do? Solve for y, right? How do I solve for y? There's two y's. I can't separate, I can't isolate them, right? Over here, there was only one y, so I could get y by itself. Same thing over here. There was only one y. I could get it by itself. Well, how do you isolate something? How do you solve for something if there's multiple there? You could say, oh, factor it, but this is not a quadratic, it's a cubic. So how do I do that? The answer is you can't. Without a graphing calculator, you can't. Okay, so we can't use that way. So there has to be another way. Well, that's the reason why we use these guys here. Okay, we use these guys here. So which one do I use? Do I use the purple or the blue? Well, what is their command? Their command is f-1 prime -3. Which one does that most look like? Which one does that most look like here? Top one, right? It most looks like the top one. That's why we're going to use the top one. Okay? That's where we're going to focus on the top one. So let me write that down. We are going to use, let me write this down over here. So f negative 1 prime of x, that is equal to 1 f prime f negative 1 of x. Okay, that's what I'm going to use. First thing I got to do, they want me to use that. It's right there. So I'm just going to plug in 3. I'm going to plug in 3 everywhere I see an x. That's the first thing I'm going to do. Okay. Plugged in 3. Now I'm going to solve it. Okay, so when we're trying to simplify, we always focus on the inside, right? This guy here. So what this green guy is asking me to do is saying, hey, when you plug in 3 for x of f's inverse, what do you get as an answer? Well, I know what I would get if I plugged f3 into f, right? It's right there. F's right there. But I don't know what I would get if I plugged in 3 for f's inverse. Yes, sir. A bunch of stuff. Thank you. Sorry, Justin. Okay. Well, this is where you make a table. This is where you make a table. Okay. So what I'm going to do is I'm going to make a table for f. I'm going to make a table for f. So f of x. What do I get for f when I plug in 3? Because they want me to plug in, sorry, not 3, negative 3. I put in a 3, but it should have been negative 3 because that's what they're asking. What do I get for x, or sorry, for f of x when I plug in negative 3? What value do I get? How do I do that? Plug in negative 3 for x. All right, do it. See what you get. Tell me what you get. Negative 37? That's what I got. Okay. But here's the thing. That green guy is not that command. It's actually the opposite command, right? It's actually the opposite command. It's actually saying, what do we get when we plug in negative 3 to its inverse? So what I have to do, oops, let me write this again, is make another table. Which point do we know is going to exist on that new table? Which point do we know for sure is going to exist on its inverse? Negative 37, comma, negative 3, right? Because that's what inverses do. They flip. So what I need to do now is I need to figure out when I plug in negative 3 here, what do I get here? That's what I need to figure out. When I plug in negative 3 for x to the inverse, what do I get for x? How do I do that? I know what I get when I plug in negative 3 to the original, but I need to figure out what do I get when I plug in -3 to the inverse. Mhm. If I plug in if I plug in -37 to where? Which one are you talking about? This guy here? Let's try it. All right, let's plug in -37, see what we get. So if we plug in -37, what do we get for x? What do we get? We can only plug it into one spot, right? We get something pretty big, right? -37 to the third is going to be like negative something huge, right? In the thousands, right? What I need is, so what I'm really trying to ask is what number here do I get that gives me -3 as an answer? That's what I'm really trying to ask. What number here for x do I plug in that would give me -3 as an answer to the original? So essentially, I'm trying to find out this. X cubed plus 4x plus 2 equals -3. That's what I'm trying to figure out. What x value would give me -3 as an answer? You probably could do this one in your head. What number would I plug in for x that would give me -3 as an answer? What number would I plug in here and here that would give me -3 as an answer? I bet you can do this one in your head. If I plug in 1, if I plug in 1 here, that gives me 1. And if I plug in 1 here, that gives me 4. So I add them together and I make 5. Plus 2 is 7, close. Let's try -1. Yeah, let's try -1. If I plug in -1 here and here, -1 cubed is -1, minus 4, -5, plus 2. I think we got our answer. So that guy goes here. So if I were to plug in -1 into the original, I would get -3 as an answer. So doesn't that mean that this point right here is going to be on the inverse? -3, 1, -1. So now can I answer the question? What is this green guy going to equal? -1, yeah. So when I plug in -3 to the inverse, I'm going to get -1. So what I'm going to do is I'm going to change that. And that green guy is no longer going to be there. What is going to be there is -1. So f prime -1. That's probably the hardest step. So now I have 1 over, the green guy is no longer there because its value is -1. F prime of -1. How do I find that? How do I find f prime of -1? Hmm? Find the derivative and then do what? There you go. So let's do that. Let's find the derivative of the original, f prime, which is going to be 3x squared plus 4, right? That's the derivative. And then let me plug in 3. Or sorry, -1. We get -1 squared is 1 times 3 is 3, so we get 7. The answer is 1/7. Okay. All right. Let's try the second one. Let's try letter B. Letter B, the command is different. Letter B, the command is different. They say now find G prime of 1. So because of that, this is the one I'm going to use. I'm going to say G prime of X equals 1 over F prime G of X. That's the guy I'm going to use. They're essentially the same thing, but one of them uses G's and one of them just uses F's. Now, what is G, though? What is G? G is the inverse. G is the inverse. So G is the same thing as F's inverse. Okay. And then they want me to plug in 1. All right. So let's do the same thing. Let's set it up. G prime of 1 equals 1 F prime G of 1. Everywhere there was an X, I plugged in a 1. So let's start with the inside here. G of 1. How do I find G of 1? So G is the inverse. So what this is saying is when you find the inverse of F, plug in 1, what do you get? That's what it's saying. But I don't have the inverse of F, right? What am I going to do? I'm going to make another table. I'm going to make 2 tables, in fact. I'm going to make 2 tables. One for F and one for G. Okay. Well, when I plug in 1 for X, when I plug in 1, actually, I probably shouldn't plug in 1 because I'll get something that's imaginary, right? If I plug in 1 for X to the original, I get 1 minus 7, which is -3. Or sorry, 1 minus 7, which is -6. The square root of -6 is not real, it's imaginary. Okay. This is what I want. Let's cut to the chase. This is what I want. I want to know this guy here. That's what I want to know. If I knew what was in that that question mark, I would be done. I can move on, but I need to figure that out. When I plug in 1 for G, what do I get? So in other words, what I'm trying to ask is, what do I need to plug in to get 1? What do I need to plug in to get 1 to the original? In other words, that's what I'm asking. Okay, so again, you could probably do this one in your head. What do I need to plug in to get 1 as an answer? 2. You plug in 2. 2 cubed is 8. Minus 7 is 1. Square root of 1 is 1. So if I plug in 2 to the original, I get 1. Which means on its inverse, instead of 2, 1, it's going to have 1, 2. So now I know the green guy is equal to 2. That was the hard part. That's always the hardest part because it's kind of a little abstract, right? I try to make it visual by using a table, but it's kind of abstract because you got to, okay, so this is this. If I plug in 2 here, I get 1, and then I got to flip them, and then that's why I use tables because it makes it visual. Okay, so now what I got to do is find F prime. So if you haven't done that, do that right now. So for F, I'm going to change it to a power, and I'm going to use the chain rule. So 1/2 x cubed minus 7 to the negative 1/2 times the derivative of the inside, which is 3x squared. Now, I don't need to clean it up because they're not asking for the derivative. They're asking me, okay, once you find the derivative, plug in 2. So I'm going to plug in 2. 2 cubed minus 7 to the negative 1/2 times 3 times 2 squared. What do I get as an answer? Okay, well, 2 cubed is 8. 8 minus 7 is 1. So 1 to the negative 1 power. 2 squared is 2, or 2 squared is 4 times 3 is 12. Negative 1/2. What is 1 to the negative 1/2? Yeah, it's just 1. Negative 1/2 means move 1 to the bottom and find the square root. Still 1. Okay. So it's 1/2 times 1 times 12, which is 6. 1/6. 1/6. Okay. All right. Okay, so now let's look at the next one. The next one is now they don't give you equations, they give you tables, which is actually nice because that's one of our steps is to make a table. Well, they've already given us the table, so we don't have to do that. Okay. So the values below give selected, the table below gives selected values for the differentiable in decreasing f and its derivative. If g is the inverse of f, what is the value of, here's our command right here, g prime 6, right? So that means we're going to use the bottom one again. And I'm going to plug in a 6 everywhere I see an x. Uh, 1 over f prime g of 6. Okay. Start with the inside. Well, I'm going to rewrite the table. I know they did the table for me, but I'm going to rewrite it because they put 2 tables in the one. They put the f of x and f prime of x together. I'm going to write it. It helps me to be a little more visual this way. So what I'm going to do is I'm going to rewrite it. I'm going to make a table just for f of x. So when I plug in negative 3 to f, I get 6. When I plug in negative 2, I get 5. When I plug in negative 1, I'm just literally copying the table. Literally just copying the table. I'm not doing anything else. I'm not including anything else that's not already there. I'm just copying the first 2 columns of the table. They don't give me f like they have in the past, but they said, hey, when you plug in negative 3, you're going to get 6 as an answer. When you plug in negative 2, you're going to get 5 as an answer. When you plug in negative 1, you're going to get negative 1 as an answer, so on and so forth, right? Now what I'm going to do is I'm going to make another table, but for g. What's the first dot going to be for g? 6, negative 3, yeah. Just flip-flop. They literally just flip-flop. Okay. So now what is g of 6 going to be? Yeah, it's right here. When I plug in 6 to G, I get -3. And then I find f prime of -3. Well, then I go back to this table here. I go back to the original table here. F prime of -3. When I plug in -3 for x, I get -1. -1 is an answer. Okay. That's how we use a table. But again, I wrote the table. I rewrote the table because it helps me see things. Because it's very hard to keep in your head. Okay, so F and G are inverses of each other. So that means they flip-flop. But when I see an actual table for G, G of 6, oh, right there. That's -3. Okay. All right. Okay, so I want you to try D on your own. I want you to try D on your own. D is kind of like earlier without the table. Okay, I'll give you some time to do that one. And then I'm going to give you a few more problems like this. All right. Okay, so let's see. We have the function of f is defined by f of x. So they give us f of x, and then they give us a point on f of x. Okay. On the graph of f. G is the inverse of f. So anytime you see these notations, you don't see these notations a lot in calculus. You don't see these notations a lot. So anytime you see this notation, this is what you're going to do. Okay? So on the AP test, you might see one of these problems. Out of 40 multiple choice problems, you might see one of them. That's how rare they are. But they are questions that aren't hard, so they're easy points. They're points that you can do. So that's why I like to cover it. Okay? So it's not covered a lot, but it's not that bad. They're not that bad. So anything when you're doing a test, anything where you're like, yeah, oh, I know how to do that. It's good. It's good. So they're easy points. Okay. So what is the value of G prime? Okay. So G prime. So we want G prime. So I'm going to use the one I've been using. So G prime of -6, 1 over F prime start with this stuff here. Okay. To do that, I want a table. I'm going to make a table. Now, my table's not going to be very big. They told me on the original that 1 -6 is a dot, right? So that means on G, it's F's, inverse, -6, comma 1 is going to be a dot. Well, luckily, I don't have to go any further because that's what I need. I need, when I plug in -6 for x, what do I get for y? 1. F prime 1. F prime of 1. Okay, so let me find derivative of f. -6x squared minus 1. F prime of 1, -6, 1 squared minus 1. -7. I'm done. Okay. All right. Compared to what we've been doing, it's not a lot of math. It's not a lot of calculations, not a lot of crunching, right? But it's just these two guys on the board that I have right there on the board, these two guys here. Those are the guys there. And they essentially say the same thing. One just uses G, one uses only F. Okay. All right. So let me give you, since we got some time, let me give you a practice problem to do on your own here. I don't want to go on to the trig stuff. We'll do trig stuff next week. Okay, so there we go. Let me try this one. Okay, try this one. Oops, sorry. Okay, so the question said we need to find f inverse of f prime of 2. That's what we need to find. So that means I'm going to use the top one because that is the one that uses the same symbols. So this guy right here. So I plugged in negative or positive 2 everywhere there was an x. Okay. I wrote down the table for f. Here's the table for f. I wrote down the table. That means f's inverse, the table is going to be flip-flopped. All right. So now I need to find the green. F, when I plug in 2 to f's inverse, that guy is right here. So that means the green stuff is going to be equal to 3. Okay. Now f prime of 3. Okay, so let me go back to the table. I didn't write those down, so let me go back to the table. F prime of 3. F prime of 3. Well, when I plug in 3 to the inverse, I get 9 as an answer. So that means it's going to be 1/9. Mm-hmm. Yeah. So look at all of your answers that we've had so far. We've done several problems. Look at all your answers. What do you notice about all your answers? What's one thing that kind of binds your answers all together? Or almost all of them. They're all fractions. And what's at the top? What's at the top of the fraction? 1. On a multiple choice test, because these will be multiple choice questions. These are not free response questions. That's a way to whittle it down. Okay, that's always a way to whittle it down, is the ones that don't have 1 over something, cross them out. Because there will always be, for like this question here, if you see this question on a test, there'll always be a 1/9, obviously, and then there will always be a 9 with it. Because they want to know if you put it over 1. Because one mistake students make is that they forget to put it over 1. So those they'll always be whole numbers, right? So if you can't make the fraction, so if it's an answer and you can't make the fraction by putting 1 on top, it's probably not going to be an answer, right? There was one answer where we got 1, right? We did get 1 as an answer one time, but I can make that into a fraction with 1, right? There was nothing like, there was never a 2 on top, a 3 on top, a 4 on top, right? There was never anything like that. That's one way. If you do that, if you can remember that, that'll usually whittle it down to like 2 or 3 options left. So you'll be able to go from there. Okay. That's a quick way of doing it, because for inverses like this, you'll always get a fraction. Okay. All right, guys. Okay, so inverse trig we'll do. It's not going to take very long. Inverse trig isn't very long. It looks a lot more difficult than it is. It's not very difficult, but it just looks intimidating. We'll do that on Monday, and then I'll give you some time to work on your assignment. Okay. The only assignment that you have that's outstanding is the one from yesterday.